All right, guys. So again, don't forget about the geometric applications last example. That was your assessment for today. I just need you to enter that answer that you have. And we'll give you partial credit even if you don't get it right on the nose. But hopefully we paid attention to our details and applied what we learned yesterday, and we all have the right answer. So again, any questions on that kind of stuff, just shoot me a message and we'll see if we can't get back with you. But today, okay, today begins kind of our polynomials breakdown, okay? So we have been up until this point building things up, right? We've been putting things together. So for lack of a better term, right, we've been building. And just to review that real quick, okay, so let's just take something like negative 2x, and then we'll go x squared plus 6x minus 1. Okay, building, right? We're going to be putting this together. So putting it together. And we're just going to distribute, right? We're going to put that 2x into each term. Again, if you want to draw the lines, you can. I stop after a while just because, right, we get to the point where we've done this so many times, we don't need to track it. But we've got negative 2x to the third minus 12x squared plus 2x. Okay, and that's our final expression. That's putting it together. We put these two products together, or these two factors together, right, to form the product. So we have factors and product. Okay. All right. So that is, right, putting it together. That's building it, right? That's actually doing the math to put things together. And so today, what we're going to be doing is what's known as factoring. Okay, now there are many different ways to factor polynomials. Okay, we're going to start with the most basic of approaches. Now, this doesn't really get us answers, but it does help us start to break things down. Okay, breaking a product back into factors. Now, what we want is its most basic, okay? So always looking for most basic, okay? Because, right, if we think about a number, okay, and factoring a number, right? So we've got, say, the example would be something like, I don't know, 48, okay? And I was like, oh, let me factor this, okay? We would break it into two factors. Now, which two factors do you want to break it into? It doesn't matter, right? We've done this in 6th grade, but I always taught them, right? Let's go with prime factors. So I know 2 is a prime number. It goes into 48. So if I break it, then I know the 2 is prime. Now, what's not prime is 24. 24 can continue to be broken. And so we're not done yet, right? We haven't completed the tasks. So the 2 carries, right? And now we have 24 being broken into more factors. And again, I would always choose 2 if I could. And that's going to be 12. And so we look at all 3 of those factors. Is it done? And the answer is no, right? 12 is not a prime factor. And we could continue, okay? So we would continue until we got 2 factors. Well, there's that 2, there's that 2, there's that 12 and a 6, okay? 2, 2, 2, 2, and 3. to where we have nothing but prime factors, right? There's nothing else that can come out of any of those factors. And that's what we're doing today. Now, we're not dealing with just a number, okay? We're going to be dealing with polynomial expressions or, binomial expressions or something, right? We're dealing with expressions that have variables in them. And so we need to be sure that we're getting everything out that we can. So looking at, right, some of our examples. So factoring is just breaking the product back into factors. So we put factors together to make a product. Now we're going to take that product and we're going to go backwards, okay? And it's very simple, right? We just need to recognize relationships as we look at some of these problems. So let's go really, really basic to start, right? So example 2, we could say we started with 3x plus 12, okay? And what we're trying to do, right, is break this into two factors, something times something else when we break it up. Now, how did they get that, right? What would they have put in to give me a 3x plus 12? And so you think of it as its term here, okay? And you look at each one and see what do they share, right? What was distributed to give me this? And then essentially we're going to undistribute, right, that number or that number in that variable if that's the case. All right, so in looking at this one, right, I have 3x and I have 12. So they don't share an x. So I know an x wasn't distributed. But if I look at 3 and I look at 12, I know 3 goes into both of those, right? So if, right, I undistribute, right, this is definitely not a mathematical term, but it does kind of get the point across, okay? What can I pull out from 3x plus 12, right? What can I pull from each of those? That's the question, right? What can I go this way with to undistribute? What can I pull out of both, right? And so the answer is a 3. If I pull a 3 out, what is left? Well, 3x divided by 3 is just x, right? Because we think of it as a as that problem, right? 3x divided by 3. And so, right, you have your 3's canceling and you just have x. And then I pull a 3 out of positive 12 and I get a 4, right? And I can always check this to make sure that, right, this is it. Now, do x and 4 share anything? Well, no, right? There is no x here with the 4, and this is a 1, and so there's nothing else to do, right? This is as good as it gets, and then this is as big as I had, okay? Now, we're not going to factor this term into products as well. Sometimes you could, if it was something like maybe an 8 that we pulled out. You might think, oh, I can keep going with the 8. That's not what we're looking for, right? We're just looking to separate this into as many factors as we can, but not get overly complicated. So this would be our answer, right? This would be as far as we could take it, okay? So kind of looking at another example, but just taking it up a notch, right? Let's say example 3, and let's go with 4y squared minus 24y, okay? So what can I take out of each one of those? Well, I'm looking at the numbers first, right? I know 4 and 24, their greatest common factor is 4, okay? So I know I can take out a 4. Now, what else can I take out? Well, if they share a variable, then I can at least take out that variable. Now, this one has 2 y's to attribute. This one only has 1. So the most I can take out is 1 y, okay? Because they both share at least 1 y. We can't take out 2 y's, right? I can't factor out 4y squared. If I did that, right, I don't have enough to give with this term. Okay, so we're going to take out the y that we can take out with that guy. Okay, and so what are we left with? What is 4y squared divided by 4y? And the answer is, well, we just get left with the y. All right, we took out the 4, we took out one of the y's, we just have y left. Negative 24 divided by 4 is going to be negative 6. And then I took the y out. Okay, so there we go, right? So the y is gone. That's our final answer, right? That is factoring out the greatest common factor. So, right, this shouldn't be too overly difficult. Let's take it up just a little bit more, right, with our next example. Kind of get a little bit more complex with things. Not too bad, but just to make sure we're recognizing what we have and what we don't. And so let's go. Example 4. And we're going to have 16bc squared and minus, or no, let's go plus 24bc. Okay, so there's our product, right? 16bc squared plus 24bc. Now these are not like terms, right? That's squared. That c to the second power is not the same as this c, so therefore these are not like terms, and they don't go together. But in looking at, right, my numbers first, 16 and 24, what is their greatest common factor? Well, 8, right? 8 is what I'm going to take from both of those. Now, looking at the letters, okay, do they each share at least one b? Yes, right? So I can take out a b. And then looking at the next term, right, we're going to have c squared and c. So I know I can only take out one c because of this second term here. Okay, so that's the factor I'm going to look to take out. Now I just kind of go one at a time, right? 16 divided by 8 is 2. Taking out the b and taking out one of the c's, I'm left with 2c. Okay, 24 divided by 8 is a positive 3, so I'm going to write plus 3. I took out a b and I took out a c, so nothing left as far as terms. And again, if you want to check your answer, just go ahead and ignore, right, that top spot and go ahead and distribute that. See what you get, combine like terms, whatever you can do, and then see, did you match the original product? And if you did, then you know you've undistributed, you factored this correctly. Okay. All right. So one of the ones that I've seen in the past that does trip my students up. Okay. I want to go over it. And that is our initial product, AB minus A. Okay. So I'm just going to let you stew on that for a minute. If you want to pause the video before I start working through it and talking through it to see if you know what's going on and what you thought should have been the answer was the answer. Okay, so in looking at this, right, there are no numbers, right? I can't factor out any kind of integer. All right, so nothing there for numbers. But in looking at the letters, okay, I have an A in this term and I have an A in this term, so I can definitely take out an A. Okay, they both don't share a B term, right, or a B variable, so the B can't come out. Okay, so there we have it, right? So we're going to start to think about, okay, so if I take an A, right, if I factor out an A from AB, I'm left with what? And the answer is just B. Okay. The second term, right, we have to understand what we have. We have negative A being divided by essentially an A, right? So negative A over A, what is that worth? Is that worth anything? I know the A's are going to cancel each other out, but what do I still have? And the question becomes, right, do you remember that we have understood ones? So we have negative 1 over 1, which becomes a negative 1. Okay, so anytime you factor a variable from itself, you're creating a 1, which is unnecessary to write. Okay, so if you think about this one, right, when I factored out the b's, okay, the b's just didn't go away. They are still there. They're worth 1, right? So that'd be 2 times 1 times c. Well, what's the point of 2 times 1? Nothing, right? So we don't essentially have that. And in this one, right, I would have b divided by b is 1, and c divided by c is 1. So that is 3 times 1 times 1. Right here, we would have 2 1s, and they're not necessary, right? So we don't write them, okay? We just leave them out and let them be. All right, so one last one to just kind of kick it up as high as we can in terms of difficulty, seeing if we can recognize, where we're at. So let's go with example 6. And I'm going to have negative 3a to the third b squared c minus 9a squared b 3c squared and plus 15a b 4 c 3. Okay, so there we go. I'll give you a second to write that one down. It looks very intimidating with all the different variables and exponents and things. But really, right, we're just going to take this one little process at a time and looking at this to factor it, right? We want to try and just take out as much as we can from every term. And so in looking at just the numbers, only the numbers first, right? We have a -3, a -9, and a 15. Now, 3, 9, and 15, I know that 3 is the greatest common factor between those three, okay? But here's kind of a lesson, if you will. We want to try and create the first term, which again, alphabetically, a to the third, a squared, a. This is the descending order we should be in, right? So this is our first term. This is our lead term in our factors, okay? So we're going to have a factor of what we're taking out, and then we're going to have the remainder of what's left after we take that out. This is going to be our lead term right here, this -3 a to the third b squared c. We want to try and make that positive, okay? It's just good form to have a leading coefficient that is positive as you move into the rest of this unit and beyond, okay? So if I just take out 3 from each term, it would definitely work, okay? So I could say I'm going to take out a 3, but the very first thing I do is create a -1 right here. And that muddies the water later, okay? So I'm going to actually take out a -3 from every term. And that's okay. We can take out positives and negatives to create what we need to create. Mathematically, it doesn't change things, right? We're just keeping that negative with the 3. Okay, so that's going to create that positive leading one. All right, next, right? One letter at a time. Okay, this one has 3 A's. This one has 2 A's. This one only 1 A to share. In which case, I know I can only take out the least, right? I have to take out the least of that variable. So I can take out an A from every term. It has to come from every term. If it's not with every term, I cannot take it out. Okay. The next one is my B's, right? I have to look at each one and see how many B's can I take out? Well, I have 2, I have 3, and I have 4. So I can actually take out 2 B's from every term. They all have at least 2 B's to give. Okay. And then looking at the C's, I have C, C2, C3. So I can only take out 1 C. All right. So going through, right, I purposefully chose -3 to create that +1. Okay, so that's going to be, right, that done. All right, I'm taking 1 A out, so that's going to leave me with A squared. I'm taking 2 B's out, so the B's are gone, right? They've created that 1, and then I've also taken the only c out, so the c's are gone. So my lead term here is just a squared, right? So now moving on, right? Let's do it again with the second term. Let's undistribute from that, right? So -9, taking out the -3, it's going to leave me with a +3. Okay, taking out 1a, taking out 2 b's, leaves me with 1b left, and taking out 1c leaves me with, right, 1c. All right, so that's the second term. Now moving on to this last one, right? So we have +15 and -3. That's going to create a -5. Taking out 1a, a's are gone. Taking out 2 b's, so I still have 2 remaining. Taking out 1c, that leaves me with, right, 2 c's remaining. And that would be, right, my final answer. Now, just to make sure that I factored out the greatest common factor in every case, look at what terms are left, right, in this expression. Are there any values that I could have taken from every one of these still, right? And if that's the case, right, I need to go back and try it again, right? If I had, right, still something to take from the numbers, it would show that these 3 are not, that they still have something to give. Are there variables left in every one, right? Is there an a in every term? And if there is, then I should have taken an additional a out, right? Same with the b, or same with the c, right? If you have a variable that's showing up again in every term, then you know you're not done because you could have taken an additional variable out. Okay. So that's as complex as it gets, right? This is just greatest common factor, right? We are essentially just undistributing the GCF, okay? That's all we're doing. That's the gist of, right, what we did today, just undistributing, okay? So easy enough, right? We're going to have maybe no homework on this concept. The next one is going to be pretty much the concept you're going to need for the next month or two, okay? So very important we get a lot of practice with it. I realize we're going kind of fast through this unit because of when we have to take the CUA by, and we got cut short a little bit on the unit with the winter storm, but we're going to get a lot of practice with this, and I have full faith and confidence in you guys that you're going to be able to handle this as we go forward. Okay. So yeah, any questions, comments, or concerns about today, guys, shoot me a message. If not, be looking for that video tomorrow to be extremely important in getting you started on pretty much the rest of the year. Okay. So let me know if there's anything I can do for you. Thanks, guys.